In this video, I will teach you how to set up a full third-person aiming system in Unreal Engine 5. This video follows on from my weapon system tutorial series, which if you're not up to date, I'll leave a link to the playlist on the screen now and also in the description below. So now, let's get straight into creating this aiming system. We're going to start by adding an input that the player can use to aim. So go to the content browser and locate your Input Actions folder. Then right-click, go to Input and select Input Action. Name this IA_aim. Now just go to File, then Save All. Then go back to the content browser and locate your input mapping context. Open it, then we want to go over and add a new mapping. Go to the drop-down and select our Aim Input Action. Then click the keyboard button, then press the input you would like to use to aim. Usually this is going to be right-click. Now we can just save and close this. Next, we want to go back to the content browser and locate your character blueprint. Here we're going to set up the system which will zoom the camera in when the player aims their weapon. So we'll start by going over to the viewport to adjust the initial position of our camera. We want to move it closer to the player character so that we have a more traditional third-person perspective. To adjust the camera's position, we're going to make some modifications to our camera boom. So select it, then in the details panel, set Do Collision Test to True. This is so our camera does not clip through objects such as walls and the ground. Next, we're going to decrease the target arm length to move the camera closer to the character. Set this to around 200. Next, we want to move the boom arm up so that it's in line with the player's torso. This is so the camera will be looking directly at where the player is holding their weapon. Setting the Z-axis to around 45 gives the camera a good position. Next, I'm also going to slightly increase the vertical angle of the camera boom. So set this socket offset value to 10. Next, we want to have the camera slightly off to the side of the character. This is so the player will be able to see past their character to where they're aiming their weapon. So set the middle socket offset value to around 50. Now you can see that the camera is slightly off to the side. We'll quickly see how this looks, so compile and save, then go back to the viewport and press play. You will now see that your character's position in relation to the camera is closer to the bottom left of the screen. Next, we're going to make it so that when the player holds right click, the camera will zoom into where they're aiming. So to do this, go back to the character blueprint, then go over to the event graph. In some space, right click and search for our aim input action. Next, we're going to add a variable that we're going to call isAiming. This should be set to a boolean. This will be used later to tell our character when to use our aiming animation. Before we set it, we first want to drag in our isHoldingWeapon variable. Then we want to drag off it and search for a branch. This will be used to only allow us to aim when the player is holding a weapon. So connect it to the started pin. Next we want to drag in our isAiming variable and set it. We want to set this one to true, then connect it to the true pin. Next, drag it in again and set it. Leave it set to false, then connect it to the completed pin. Next, drag off here and search for a timeline. Using a timeline will allow us to smoothly transition between two different camera positions. Name the timeline something like TL_aiming. Double click to open it. Then we want to go over to Add Track, then Add Float Track. Name the track something like Aim Alpha. Next, we want to change the length of our track to how fast we want our aim down sight speed to be. So around 0.2 seconds is good for this. We're going to add 2 points to this graph. The first for the camera position when the player is not aiming, and the second for the camera position when the player is aiming. So to add a point, hold Shift then left click on the graph. This is for when the player is not aiming, so the camera position will just be the default we set for the character. This means we can set both its time and value to 0. Next, we want to hold Shift and left click again to add another point. This will be for when the character is aiming. So we want to set the time to the full duration of the track, which is 0.2 seconds. Then we want to set the value to 1. This is all set up, so we can now go back to the event graph. Here we're going to use our timeline to change the length and angle of our camera boom when the player aims in. So start by dragging off the alpha pin and searching for a lerp. This node will allow us to smoothly change between two different camera boom lengths. So we want to disconnect the alpha from the A pin, then reconnect it to the alpha pin. We want to set the A value to our player's default non-aiming camera boom length. which we set to be 200. We then want the B value to be less than that, so that when the player aims, the camera boom length is decreased and the camera zooms in. So halving it to around 100 should be good for this. Next, we want to drag the camera boom into the graph so we can set its new length. So drag off it and search for set target arm length. Connect the target arm length pin to the lerp, then connect it to the update pin on the timeline. This will now smoothly decrease the length of the arm when the player aims in. When we aim, we also want to change the angle of the boom arm. This is so that the camera is moved further to the right of the player so we can see where we're aiming. So select the lerp, copy it, then paste it below. Then join up the alpha pins. We want to set the A value to how far we angled the boom arm to the right of the character, which we set to 50. The B value will be the new angle we move to when we aim in, so we only want to increase this by a small amount, so I'm going to set it to 70. Next, drag off the camera boom and search for a set socket offset. Connect this up. Next, we only want to rotate it in the Y-axis, so right-click on the socket offset pin and split it. We didn't change the X value, so we can leave this set to 0, but we did set the Z value to 10, so we can set that here. The Y value is the one we're changing, so we can just plug that into the lerp. Next, we want to come back over here and connect where we set is aiming to false to the reverse pin. This is so when you release right-click, your character stops aiming. We can now test this out, so compile and save, then go back to the viewport and press play. If you pick up a weapon, then hold right-click, you will see that the camera now zooms in to where the player will be aiming. Then if you release right-click, the camera zooms back out. Next, we're going to move on to setting up an aim offset. An aim offset will allow us to smoothly blend between different aim animation poses. This means if we aim the camera up, down, left or right, we will have an aiming animation that points the weapon in that direction. We're going to need some new animations for this, so go to the link I've left in the description and download this animation starter pack. Once you have added it to your project, you can open the content browser and you'll see the animation starter pack here. Inside we have all these animations which we can use for our project. The ones we'll be using for our aim offset are these two aim space animations. This first one will give us all the different directional poses we'll need for when the player is aiming their weapon. This second one will give us all the different directional poses we need for when the player is hip firing their weapon. Before we can use these animations, we first need to retarget them to our character mesh, so I'm going to quickly show you how to do this. So start by opening up the content browser. Then we're going to right-click and add a new folder. Name this IK. Open it, then right-click and add another folder. Call this Rigs. Open it, then right-click again, then go to Animation, then Retargeting, and select IK Rig. Name this IK_mannequin. This one will be for the character used for our new animations. So go over to the Preview Skeletal Mesh and look for the Mannequin Skeletal Mesh from the animation pack. You can see that this is the right one because if you look at the path in the box below, it shows it's from the Animation Starter Pack folder. Now that we have our character mesh, we can move on to setting up the bones. First, we want to right-click on the pelvis and set it to the retarget root. Next, we want to hold Shift to select all of the spine bones, then click Add New Chain. The chain name should be Spine, then we can just click Add Chain. Next, select the left clavicle, then click Add New Chain. Rename it to Left Shoulder. Then just click Add Chain. Next, select the left upper arm, lower arm and hand. Then we'll add a chain called Left Arm. Next, we need to add chains for all of the separate fingers. So select all of the index bones, then add a new chain and call it Left Index. Next, do the same for the middle finger, this time calling it Left Middle. Add another chain for the pinky bones, this time calling it Left Pinky. Do the same for the ring finger bones, calling them Left Ring. Then finally do the same for the left thumb. Repeat this process for the right side. Next, we need to add a chain for the neck, so select it, then click Add New Chain, make sure it's called Neck, and then click Add Chain. Then do the same for the head, making sure that the name is Head. Next, select the left thigh, calf, and foot. Click Add New Chain, make sure it's called Left Leg, then click Add Chain. Then finally, repeat this for the right leg, making sure it's called Right Leg. Now our rig for the mannequin is fully set up, so we can save and close this. Then we can move on to creating the IK rig for the character we are using. So right click in the content browser, go to Animation, then Retargeting, and select IK rig. I'm going to name this IK_soldier. Open it, then go to the Preview Skeletal Mesh dropdown, and select our soldier mesh we downloaded off Mixamo. We're going to repeat the retargeting process, so start by right clicking on the hips, and setting it to the retarget route, then go through all the bones, creating chains that have the exact same names as the ones we made in the mannequin IK rig. Once you've done this, you can just save it and close it. Next, we're going to create an IK retargeter. This will use the rigs we just created to transfer our animations from the mannequin to the soldier. So in the content browser, I'm going to right click and create a folder for this. I'm going to call it Retargeters. Open it, then right click, go to Animation, then Retargeting, and select IK Retargeter. Name this RTG_mannequin2soldier. Then open it. Here we want to set the source to our mannequin IK rig, then set the target to our soldier IK rig. If you go over to chain mapping, you can see that we have all the different chains we created. So we just want to make sure that all of these match for each rig. If they don't, you can just go to the drop downs and change them. As you can see, both characters have different starting poses, so we're going to adjust the arms of the mannequin so that they match. So click here to change it to source, then click here to change it to the editing mode. If you can't see the bones on the characters, go to Character, then Bones, then select All Hierarchy. Next, you want to use different perspectives to line up the arm bones of both characters. So start by going to the left perspective, then make sure we're in the wireframe view. We're going to want to rotate the bones in the world space. So click this button so it shows a world icon. Next, we're going to go through rotating all of the shoulder and arm bones so that they line up with the other character's bones. Once you've done this, we're going to switch it to the top perspective. Here we're going to do the same, lining up the shoulder and arm bones with the ones of the other character. Once you've done this, go back to perspective. Now if we go over to the asset browser, then double click on an animation, you will see that the animation from the mannequin can now be played on the soldier. We can now transfer all of these animations to our character, but first I'm going to quickly go to the content browser and create a folder for them to go in. I'm going to name this folder Aim Animations. Now we can go back to the retargeter, then hold Shift and left click to select all of the animations, then click Export Selected Animations. Find the Aim Animations folder we just made, then click Export, then click Export again. We have now retargeted all of these animations to our character. So now open up this Aim Space Iron Sights animation. This is where we're going to get all of our aiming animation poses from for our animation offset. Before we start creating the poses, I'm going to quickly go to the content browser and create a folder to put them in. I'm going to call this Aim Poses. Now we can go back to this animation and we're going to create an animation pose for when the player is aiming the weapon directly forward. This occurs at frame 0 in the animation. So make sure you're at that point, then go to Create Asset, then Create Animation, then select Current Pose. Rename this to Aim Forward. Then we want to find our Aim Poses folder, select it, then just click OK. We've now created this Aim Forward pose, so now we want to go back to the content browser and reopen the Aim Space Iron Sights animation. We're going to move across to frame 10 where the character is aiming the weapon upwards. We're going to follow the same steps, so create asset, then create animation, then select current pose, rename it to Aim Up, then find the Aim Poses folder, select it, then press OK. Now go back to the content browser and open up the animation again. We're going to repeat this process, moving forward 10 frames each time until we have all 9 directional animation poses. Now that we have created all the animation poses we need, we're going to move on to creating our aim offset. So go to the content browser, right-click, create a new folder, and call this Aim Offsets. Open it, then right-click, go to Animation and select Aim Offset. Select our character's skeleton, then we're going to name this AO_aiming. If you open it, you'll see that it looks very similar to a blend space. This is because it works in a similar way, allowing us to blend smoothly between different aiming animations depending on where the player is looking. So to set this up, we're first going to go to the horizontal axis, where we're going to change the name to yaw. Then we want to change the minimum axis value to -90. Then change the maximum axis value to 90. We're then going to go to the vertical axis and name it pitch, where again we're going to set the minimum value to -90 and the maximum value to 90. Next we need to set the preview bone pose. So for this I'm going to go to the content browser, then right click on our aim forward animation and duplicate it. I'm going to name this Aim Forward Idle. Then I'll just go back and set it here. Before we can use our animation poses in the aim offset, we need to make some changes to them. So start by opening up the aim down animation. We want to scroll down until we get to where it says Additive Anim Type. We want to set this to Mesh Space. This will allow for our aim offset to stay perfectly aligned with the character's direction. Next we want to set the base pose type to Selected Animation Scaled. This makes it so that we can use our aim forward idle as a base animation pose. So set the base pose animation to our aim forward idle animation. Next we just need to repeat this for all of our aiming animation poses. but make sure not to do it for the aim forward idle animation. Once you've done this, go back to the content browser and open up your aim offset. Once here, we can start dragging our aim poses into the graph. First, drag the aim forward animation into the center of the graph. Select it, then make sure both the yaw and pitch values are set to 0. Next, drag the aim down animation to the bottom center of the graph. Select it, then make sure the yaw is set to 0 and the pitch is set to -90. Next, drag the aim left to the middle left of the graph. The yaw should be set to -90 and the pitch should be set to 0. Next, drag the aim down left to the bottom left of the graph. Then the aim up left to the top left of the graph. Drag the aim right to the middle right of the graph. Then select it and make sure the yaw is set to 90 and the pitch is set to 0. Next, drag the aim right down into the bottom right, then the aim right up into the top right of the graph. Finally, drag the aim up into the top middle of the graph. Select it, then make sure the yaw is set to 0 and the pitch is set to 90. This is all now set up, so now we need to go back to the content browser and find our animation blueprint. Open it, then go over to the event graph. Find your update animation event, then move over to the end. Here we're going to drag in our player character reference variable, then drag off and search for a get is aiming. Right-click on the pin and promote it to a variable. This is going to be used to tell our character when to use the aim offset. Connect it up. Next, we're going to calculate our character's pitch and yaw. These values effectively tell us which direction the player is looking. So to get these, first drag off the player character reference and search for a get base aim rotation. This gives us the direction the player is looking. Next, drag off the character reference again and search for a get actor rotation. This gives us the direction the character is facing. Next, drag off here and search for a delta rotator. Then plug the get actor rotation into the B pin. This node gives us the difference between where the character is facing and where they are aiming. This gives us a value of how far the player is aiming away from the character's forward direction, and therefore allows us to rotate just the upper body for aiming rather than turning the whole character. To get the separate pitch and yaw values, right-click on this pin and split it. Then right-click on the pitch and promote it to a variable. Name this pitch. Then connect it up. Next, right-click on the yaw pin and promote that to a variable. Name this yaw. Then connect it up. Next, come over to the animation graph. We only want to use an aim offset if the player is holding a weapon, so disconnect the graph just before the blend poses by ball. We also only want to use this aim offset if the player is aiming their weapon, so come over and copy this blend poses by ball node and paste it into the space. Connect it to the true pin. Then drag in the is aiming variable and get it. Connect this to the active value pin. The true blend time value is how quickly the character's animation will go from not aiming to aiming, so it's effectively their aim down sight speed. Then the false blend time is how quickly they go from aiming to not aiming. We want these values to be the same as the length we set for the timeline to zoom the camera in the player character. We use 0.2, so we're going to set that for both of these values. Next, we're going to drag in our aim offset, then connect it to the true pose pin. As you can see, we have a yaw and pitch pins. So what we can do is drag in the yaw variable, get it, then connect it up. Then we can just do the same for the pitch variable. Next, we can just connect the blend poses by enum to the base pose. Then we just want to come over here and swap this animation for our aim forward idle animation. Then make sure to connect it to the rifle pose pin. This is all the code needed for our aiming animation offset, but we're also going to need a hip fire aiming offset. We will set this up a little bit later, but for now we're just going to copy and paste these nodes below, then connect it to the false pose pin. Then we can just replace this animation with the idle rifle hip animation. If we compile and save, then go back to the viewport and press play, if you pick up a weapon then aim down sight, you will see that the character's upper body now turns to face the direction they're aiming. There are a couple issues that we have at the moment, the first being that the left hand is not fixed to the weapon and moves around often through the gun mesh. This is something that we will fix in a future video. Also, the player can't rotate 360 degrees at the moment. This is something that we'll fix later on by adding a turn-in-place system. The final thing is that since we're using new animations, the gun mesh isn't positioned properly in the player's hands, so we're going to fix this by moving the socket. To do this, go to the content browser and locate your character's skeleton. Open it, then go to the preview animation drop-down and search for our aim forward idle animation. Next, I'm going to delete the magazine preview asset. So to do this, I just right-click on the mag socket, then go to remove all attached assets. Next, I'm going to scroll down to the rifle socket. Here I'm going to right-click on it, then go to add preview asset. Then I'm going to click on the mesh for the main body of the AK. I'll then rotate and move the socket until I'm happy with the position of the gun mesh. Now that the gun is better positioned, I'm going to move on to creating an aim offset system for hip firing. This system will follow very similar steps to the aim offset we just made. However, this time we'll be using the hip fire animations. So to start, go to the content browser and locate the aim space hip animation. Open it, then pause it. Then go to the first frame where the character is pointing the gun forwards. We're going to follow the same steps that we did for the aim animation, so go to create asset, then create animation, select current pose, then name it something like hip forward. Then we want to locate our aim poses folder, then select it and click OK. Now we have our first pose, so we want to go back to the content browser and open up the aim space hip animation again. As we did before, we're going to keep going forward 10 frames, then create an animation for each pose. Once we have done this, we want to go to the content browser and open the aim poses folder. Here we want to create our base pose, so right-click on the hip forward animation and duplicate it. Name this hip forward idle. Again, we're going to go through all these animation poses and set them up so that they can be used in an aim offset. So open the first one, then go over to additive aim type and set it to mesh space. Next, set the base pose type to selected animation scaled. Then we can set our base pose animation to the hip forward idle animation. Now we can just save this, and we're going to repeat it for all the other animation poses, excluding the hip forward idle animation. Now that all our hipfire animation poses are set up, we can move on to setting up our aim offset. So open up the content browser and open the aim offsets folder. Here we're going to right click on our aiming offset and duplicate it. Name this AO_hip. Open it, then we're going to delete all the animations currently on the graph. Next, come down to Preview Base Pose and set it to the hip forward idle animation. Next, we can start dragging our animation poses into the graph. So first drag in the hip down and put it in the bottom middle. Select it, then make sure the yaw is set to 0 and the pitch is set to -90. Next, drag the hip forward into the center of the graph. Select it, then make sure both the yaw and pitch are set to 0. Next, drag the hip left into the left middle of the graph. Select it, then make sure the yaw is set to -90 and the pitch is set to 0. Next, drag the hip left down into the bottom left of the graph, and drag the hip left up into the top left. Drag the hip right into the middle right of the graph. Select it, then make sure the yaw is set to 90 and the pitch is set to 0. Next, drag the hip right down into the bottom right of the graph. Then drag the hip right up into the top right of the graph. Finally, drag the hip up into the top middle of the graph. Select it, then make sure the yaw is set to 0 and the pitch is set to 90. Now we can just save this, then go over to our animation blueprint to set it up. When you're in the animation graph, you want to go over to the asset browser and drag in our hipfire aim offset. First, move this across, then we want to connect the aim offset to the false pose on the blend poses by bool. Next, we need to input the yaw and pitch variables so we can just copy and paste them from here, then connect them both up. Next, connect the blend poses enum to the base pose. Now we want to replace this animation with our hip forward idle animation. This is all now set up, so if we compile and save, then go back to the viewport and press play, if we pick up a weapon, we should now have a working hipfire offset. Next, we're going to work on adding a turn-in-place system. What this does is when the player aims a certain number of degrees to the left or right, the character will turn to face that new direction. This system will work when the player is aiming, but also when the player is hip firing. So to set this up, we first need to go to the player character blueprint. Here we want to add a new variable called isTurning. We want to make sure that this is set to a boolean. This will tell us if the player is currently performing a turn in place. We also want to create another variable called locked_target_yaw. We want to set this to the type float. This will store the yaw value that will be turning to face. Now right click on the graph and create a custom event. Name this turnPlayer. We want to trigger this event every time the player uses the mouse to look around. So come up to your look input action. Here we want to just drag off the end and search for our turnPlayer event. Now we can just come back down to our event where we're going to set up our turn in place functionality. Start by dragging in the isTurning variable, then drag off it and search for a branch. Connect this to the custom event. If this returns false, it means the player is not currently turning. So we want to calculate the point where the player will be turning to. So right click on the graph and search for a get control rotation. Then right click again and search for a get actor rotation. Drag off here and search for a delta rotator. Then connect the get actor rotation into the B pin. This will calculate the difference between the direction the player is aiming and the direction their character is facing. Next, we only need the yaw value from this, so we're going to right click on the pin and split it. Next, drag off the yaw pin and search for an absolute float. What this node does is convert the yaw value, which could be negative or positive, into a value that is always positive, which is what we need because we only want to know how big the difference is. Next, drag off this and search for a greater than. In here, we want to put a value, which is how many degrees the player needs to look either left or right before their character turns. So a value of 45 is good for this. Next, we want to drag off this and search for a branch. Connect this to the false pin. Next, if this returns true, it means the player has either looked left or right 45 degrees from the direction they were initially looking. Therefore, we want to calculate the direction that we want the player to turn to face. So now we want to drag in the isTurning variable and set it. Set this to true and then connect it to the true pin. Next, right-click and search for a Get Control Rotation. Right-click on the pin and split it. Next, we want to drag in our locked target yaw variable and set it. Connect it to the yaw pin and also connect it to the isTurning variable. This will now store the yaw value that we want to turn the player to face. This bit of code is done, so select all the nodes and move them out the way. Next, come back to the isTurning branch. If this returns true, we want to set up the code that will rotate the player to face the locked target yaw direction. So start by right-clicking and searching for a Get Actor Rotation. Next, drag in our locked target yaw variable and get it. Next, we want to turn the yaw value into a full rotator so that we can smoothly rotate the player from their current rotation to this new rotation. So right-click and search for a Make Rotator. Then connect the locked target yaw to the yaw pin. Next, drag off the Get Actor Rotation and search for an R-Interp2. This is the node that will smoothly rotate our player from its initial rotation to the new rotation. Connect the Make Rotator to the target. Next, drag off the Delta Time pin and search for a Get World Delta Seconds. This provides the exact time since the last frame, so that our turn in place speed is consistent and smooth. The interp speed is how fast the rotation blends towards the target, so a lower value will make it slower and smoother, and a higher value will make it snappier and faster. Using a value of 8 to 10 is usually good for this. Next, we want to drag off here and search for a Set Actor Rotation. Then we just want to connect this to the true pin. Next, we want to check if we're close enough to our target yaw value that we can stop turning. So to do this, come back over here, copy these nodes, and paste them back over here. Drag this below, then drag off the Make Rotator and search for a Delta Rotator. Then connect the Get Actor Rotation to the B pin. This will give us how close we are to the target yaw. So right-click and split this pin. Then again we want to drag off and absolute it. Next, drag off and search for a less than. Set this value to 2. Then drag off and search for a branch. This will let us know that the player has pretty much reached the new target yaw. So now connect this to the Set Actor Rotation. So if this returns true, it means the player has turned enough to reach their new rotation. So we can drag in the isTurning variable and set it. Leave it set to false, then connect it to the true pin. This is all now set up so we can compile and save, then go back to the viewport and press play. You will see that if you turn about 45 degrees to the left or right, the player will turn to face that direction. At the moment, we're able to use the arrow keys to rotate the player. However, in a third-person game, you generally want the player to always be facing the direction the camera is pointing. We can quickly change this in the character blueprint. So open it, then go to Class Defaults. In the Details panel, search for Orient Rotation to Movement. Then set it to false. Now if you compile and save, then go back to the viewport and press play, you will see that the character's rotation is no longer controlled by the movement inputs. Next, we're going to work on making it so that when we fire a bullet, it will hit exactly where we're aiming. So to help with this, I'm going to quickly add a temporary crosshair to our player's HUD. So go to the content browser, open the UI folder, and then open the HUD. For the crosshair, I'm just going to search for an image, then drag it in. With it selected, I'm going to go to Anchors and set it to the center. Then I'm going to set its X and Y positions to 0. Come down to Alignment and set both of these to 0.5. Next, I'm going to make the crosshair quite small, so set the X and Y size to 2. This is all now set up so we can compile and save. Then we want to open the content browser, then go to the Weapons folder, and open the base weapon blueprint. Once we're in here, we want to come over to where we create our line trace for our bullet. Then on that multi-line trace, we want to set the draw debug type to for duration. This is just so we can see where our bullet trace is hitting. If we compile and save, then go back to the viewport, then go to the content browser and drag in an enemy so that we have something to aim at. Then if we just click play and pick up a weapon, then aim and shoot at the enemy, you will see that the bullets are not landing directly where our crosshair is. This is because we're currently using the gun's position to calculate where our bullet trace goes. Instead, we're going to want to use our camera's position. So to set this up, first go back to the base weapon blueprint. Over by the multi-line trace, we want to disconnect this get world location. Next, we want to drag in our player character reference. Then drag off and search for a get follow camera. Then we just want to connect this to the get world location. This is connected to the started pin of the multi-line trace. So now our line trace will start at the location of the third person camera. Next, we want the line trace to be at a range in front of our player camera. So start by disconnecting this get forward vector. Next, drag off the follow camera and search for a get world rotation. Then plug that into the get forward vector. This now places our line trace endpoint directly in front of the player camera from a range given from the weapon that the player is currently holding. If we compile and save, then go back to the viewport and press play, then pick up a weapon and shoot it, you will see that we are now shooting exactly where our camera is aiming. This does mean that our line trace no longer starts at the barrel of our weapon. However, this does not matter because our line trace is not visible to the player. So now we can come back to the base weapon blueprint, go to the multi-line trace and set the draw debug type to none. Also, something to note is that our muzzle flash particle effect will still spawn at the barrel of the gun as we've used the shot arrow location to spawn it, rather than the start of the line trace. Now we can just compile and save this. There is one last thing I'm going to go through in this video, and that is how to add different aim down sight speeds for different weapons. So to do this, first come back over to the base weapon blueprint. We're going to add a new variable to this called aim speed. Then we're going to set the type to a float. If we compile and save this, we will now be able to access this variable in all of the children weapons of this blueprint. So I'm going to go to the content browser and open up the base full auto weapon blueprint. Then I'm going to go over to class defaults where I can set the aim speed for this weapon. For this one, I'm going to set it to something quite slow like 0.4. Next, I'm going to go to the content browser and open the semi-auto weapon. In class defaults, I'm going to set the aim speed to something quite quick like 0.1. Next, we need to use these values to set how quick our aim animation will play. So to do this, go over to the animation blueprint. You want to come over to the event graph, then you want to drag off the player character reference and search for a get current weapon. Next, we want to drag off this and search for an is valid. This makes sure that we're only trying to get the aim speed when we're actually holding a weapon. Connect this up and add a reroute node. Next, drag off the reroute node and search for the get aim speed. Then we want to right click on the pin and promote it to a variable. Then connect it to the isValid pin. Now that we have access to this variable, we're going to go over to the animation graph. This true blend time pin corresponds to how fast the character's animation aims in, and the false blend time is how fast the animation aims out. So drag in the aim speed variable and get it, then connect it to both the pins. This is everything for the animation, so now we need to go back to the player character blueprint, where we're going to change how quickly the third person camera zooms in when the player aims their weapon. So first, come over to our aiming input event. Here we want to double click on the timeline to open it. We want to set the length of the timeline to 1, because this allows us to easily use our aim speed variable to change the play rate of this timeline, and therefore change how quickly we aim in and out. We also want to select this point and make sure the time is set to the full 1 second. Next, we can go back to the event graph, and we want to find our spawn weapon event. We want to come over to where we spawn our player's current weapon. Then come over here select these nodes and move them across a bit to make some space. Then, under Components, we want to drag in our aiming timeline. Then we can drag off it and search for a set play rate. This effectively sets how fast our timeline will play. Connect this up. For the new rate pin, we want to use our current weapon's aim speed. So, drag off this current weapon variable and search for a get aim speed. Next, we need to get the reciprocal of our aim speed. The reciprocal will just be 1 divided by our aim speed. So right-click and search for a divide. Plug the aim speed into the bottom pin, then set the top pin to be 1. The reason we need the reciprocal of our aim speed is because, for example, one of our weapons has an aim speed of 0.1, which is 10 times faster than the timeline's current length of 1. So to get it to be 10 times faster, we'd actually need to plug 10 into the new rate on the set play rate. So to get this value of 10, we can just divide 1 by our aim speed of 0.1. Connect this to the new rate. Now, if we compile and save, then go back to the viewport and press play, then pick up the full auto weapon, you will see that it has a very slow aim down sight speed. If you then go and pick up the semi-auto rifle, you will see that the aim down sight speed is much faster. You should now have a full third-person aiming system using aim offsets in Unreal Engine 5. In the next video, I'll be covering how to add some better animations to your character, including 8-way movement animations and turn-in-place animations. If you would like to be notified when this video comes out, hit subscribe and click the notification bell. If you found this video helpful, please consider giving it a like and also commenting down below what you would like me to cover in future videos. If you would like personal assistance with these tutorials or on your own Unreal Engine projects, check out my Patreon in the description below. Thank you so much for watching.